Welcome. Every organization faces the same challenge. There are always more opportunities than resources, more projects than budget, more ideas than people, more priorities than time. The question isn't whether good opportunities exist. The question is which opportunities deserve investment. Today we'll explore how organizations use TOPSIS, AI, and Python to make better decisions. The following example will be used throughout the video. An enterprise project portfolio prioritization, in which a company has 10 proposed projects, $20 million budget, limited staff, and competing strategic goals. Executives must decide whether to fund, delay, or reject. Executives will be using the following as the evaluation criteria: strategic alignment, return on investment, ROI, revenue impact, customer impact, risk, cost, and time to deliver. The viewer will see this during AI prompting, TOPSIS workflow, Python workflow, dashboard examples, executive summary examples, and boardroom presentation examples. Let's begin. Part 1. Why decision-making is hard. Section 2. The cost of poor decisions. Poor decisions are expensive. Organizations routinely fund low-value projects, delay high-value initiatives, misallocate capital, overlook risk, and miss strategic opportunities. Most of these failures occur because decision-making is inconsistent. TOPSIS was designed to help solve this problem. Part 1. Why decision-making is hard. Section 3. Why simple ranking fails. Suppose one project has the highest ROI, another has the lowest risk, another is fastest to deliver. Which one is best? Simple ranking breaks down immediately. Business decisions almost always involve competing objectives. This is where TOPSIS becomes valuable. Part 2. What is TOPSIS? Section 4. What TOPSIS really means. TOPSIS stands for Technique for Order Preference by Similarity to Ideal Solution. The name sounds complicated. The idea is simple. The best option should be closest to the ideal solution and furthest from the worst solution. TOPSIS mathematically measures both. Part 2. What is TOPSIS? Section 5. Why TOPSIS was invented. TOPSIS emerged from the field of multi-criteria decision analysis. Organizations needed a better way to evaluate alternatives when multiple objectives mattered simultaneously. TOPSIS became one of the most widely adopted approaches because it is intuitive, transparent, and relatively easy to implement. Part 2. What is TOPSIS? Section 6. When TOPSIS should be used. TOPSIS is ideal when multiple criteria matter. Trade-offs exist. Alternatives must be ranked. Decision logic needs to be transparent. Executives need a defensible decision process. Part 2. What is TOPSIS? Section 7. When TOPSIS should not be used. TOPSIS is not appropriate for every problem. If only one criterion matters, simpler methods may be better. If data quality is poor, results may be misleading. If prediction is required, machine learning may be a better choice. TOPSIS ranks alternatives. It does not predict the future. Part 3. Enterprise example. Section 8. The portfolio prioritization problem. Imagine 10 projects competing for funding. Leadership can only fund 4. The challenge is determining which projects create the most value. This is a classic TOPSIS problem. Part 3. Enterprise example. Section 9. Selecting criteria. The leadership team agrees on 7 evaluation criteria. Strategic alignment. ROI, revenue impact, customer impact, risk, cost, time to deliver. These criteria reflect both financial and strategic objectives. Part 3. Enterprise example. Section 10. Weighting criteria. Not every criterion is equally important. Executives assign weights reflecting organizational priorities. A growth-oriented company may emphasize revenue. A mature company may emphasize risk reduction. Weights translate strategy into mathematics. Part 3. Enterprise Example. Section 11. The 7 TOPSIS steps. TOPSIS follows 7 primary steps. Build the decision matrix. Normalize data. Apply weights. Determine the ideal solution. Determine the negative ideal solution. Calculate distances. Rank alternatives. The mathematics supports the decision. The decision remains a leadership responsibility. Part 4. AI before TOPSIS. Section 12. Using ChatGPT to select criteria. ChatGPT can help identify candidate evaluation criteria. It can suggest overlooked dimensions, challenge assumptions, and improve decision quality before analysis begins. Part 4. AI before TOPSIS. Section 13. Using AI to validate criteria. AI can identify overlapping criteria, missing factors, potential bias, and logical inconsistencies. Think of AI as a decision design assistant. Part 4. AI before TOPSIS. Section 14. Using AI to generate weighting scenarios. AI can create multiple strategic weighting models. Growth strategy, risk strategy, innovation strategy, cost containment strategy. Executives can compare outcomes before making final decisions. Part 5. Python implementation. Section 15. Preparing data in Python. Using pandas, analysts organize project data into a decision matrix. Rows represent projects. Columns represent criteria. This becomes the foundation of the TOPSIS workflow. Part 5. Python implementation. Section 16. Performing TOPSIS calculations. Using NumPy, analysts normalize values, apply weights, calculate ideal solutions, measure distances, and generate final rankings. What once required extensive manual effort can now be completed in seconds. Part 5. Python implementation. Section 17. Creating executive visualizations. Using Matplotlib, analysts transform rankings into executive-friendly visuals. Bar charts, portfolio maps, heat maps, funding recommendations. Visualization bridges analytics and decision-making. Part 5. Python implementation. Section 18. Building an executive dashboard. A dashboard allows leaders to interact with results, explore rankings, test scenarios, adjust weights, and evaluate strategic trade-offs. Part 6. AI after TOPSIS. Section 19. Using AI to interpret rankings. AI can explain why one project outranks another. It can identify drivers, trade-offs, and hidden insights. This transforms scores into understanding. Part 6. AI after TOPSIS. Section 20. Generating executive summaries. AI can automatically create executive summaries, highlight key findings, describe risks, and explain recommendations. Part 6. AI after TOPSIS. Section 21. Creating boardroom recommendations. AI can convert rankings into action plans. Fund, delay, monitor, reject, helping leaders move from analysis to execution. Part 7. TOPSIS versus other methods. Section 22. TOPSIS versus weighted scoring. Weighted scoring adds points. TOPSIS measures distance from ideal and worst-case solutions. Both are useful. TOPSIS provides deeper insight into trade-offs. Part 7. TOPSIS versus other methods. Section 23. TOPSIS versus PCA. PCA reduces variables. TOPSIS ranks alternatives. These methods often complement each other rather than compete. Part 7. TOPSIS versus other methods. Section 24, TOPSIS versus AHP. AHP helps determine priorities and weights. TOPSIS uses those weights to rank alternatives. Many organizations use both together. Part 7. TOPSIS versus other methods. Section 25. TOPSIS versus machine learning. Machine learning predicts outcomes. TOPSIS ranks alternatives. Prediction and prioritization are different problems. Organizations often use both. Part 8. Executive storytelling. Section 26. How executives want results presented. Executives rarely want formulas. They want recommendations, implications, risks, opportunities, and next steps. Part 8. Executive storytelling. Section 27. Sensitivity analysis. What happens if weights change? Do rankings remain stable? Sensitivity analysis helps determine whether recommendations are robust. This is one of the most important steps in real-world TOPSIS applications. Part 8. Executive storytelling. Section 28. Executive storytelling example. We evaluated 10 projects using 7 criteria. Project Alpha consistently ranked first across multiple strategic scenarios. It delivered the strongest combination of value, alignment, customer impact, and manageable risk. Therefore, we recommend immediate funding. That is how analytics becomes executive storytelling. Part 9. Wrap-up. Section 29. Common TOPSIS mistakes. Poor criteria. Duplicate criteria. Weak data. Arbitrary weights. Ignoring sensitivity analysis. Treating rankings as absolute truth. These mistakes reduce decision quality. Part 9. Wrap-up. Section 30. TOPSIS limitations. TOPSIS is powerful, but it depends on assumptions. Data quality matters. Weighting matters. Context matters. TOPSIS informs decisions. It does not replace leadership judgment. Part 9. Wrap-up. Section 31. TOPSIS executive cheat sheet. If you remember only one thing from this video, remember this: TOPSIS helps organizations identify alternatives that are closest to ideal performance and furthest from poor performance. 7 steps, 1 framework, better decisions. Appendix Section 32. Mathematical Appendix. For analysts and data scientists, TOPSIS involves normalization, weighted decision matrices, ideal solutions, negative ideal solutions, Euclidean distances, and closeness coefficients. The mathematics is important, but the business value comes from making better decisions. The formula serves the decision, not the other way around. A call to action. Thank you for watching. Today we explored how organizations can transform complex decisions into better decisions using TOPSIS, artificial intelligence, and Python. We saw how to identify the right criteria, apply meaningful weights, evaluate alternatives objectively, test assumptions, communicate recommendations, and create executive-ready stories. Remember, TOPSIS is not about finding a perfect answer. It is about creating a transparent, structured, and defensible decision process. When combined with AI, Python, and executive judgment, it becomes a powerful framework for prioritizing what matters most. If you enjoyed practical analytics, optimization, AI, decision science, and business intelligence content, please subscribe. Thank you for supporting SRR Strategic Intelligence. Until next time, turn data into insight and insight into better decisions.